To make sure you never end up having to sing the blue tarp blues, get a storm-ready roof. Roofing is a primary line of defense against keeping hurricane winds and wind-driven rain out of your house, but it has historically been one of the weakest elements of that line of defense. 95% of hurricane damage claims include roof damage. Damage to the roof covering during a storm can lead to substantial water damage, followed by mold. But a storm-ready roof can survive hurricane-force winds, rain, and hail. Improving your roof can save your home. This presentation will focus on asphalt shingle roofing and wood frame houses. This home has spotty loss of shingles throughout the roof. It appears to have the roof decking intact, but possibly water damaged. Now look at the top right photo. That shows a shingle that's not properly stuck to the shingle below it. It's an easy target for wind to get under. You'll see how you can attach the shingles better so they resist that uplift and stay put during a storm. This damage was caused by shingles blowing off, then the roofing felt underlayment tearing away, which is pretty typical once the shingles go. Many houses have a weak link in the connection of roof decking to the rafters. This is especially true in older homes. The reason is that nail sizes and spacing used in the past don't provide enough resistance to extreme uplift forces of strong wind. Unless you are certain that your roof decking, also called sheathing, is installed according to the current recommendations for your wind hazard zone, you should assume that the fastening is substandard and vulnerable. Strong winds can cause as much as 100 pounds per square foot of uplift force, in other words, suction, on your roof. Tests have shown that roof sheathing attachment with these older nailing patterns can be pulled away with only 40 pounds of uplift pressure. Use of longer 8D nails instead of the 6D nails typically used in older homes increases that resistance to 70 pounds per square foot, but that's still not enough. In addition to inadequate nail size, attachment flaws are very common, including shiners. That's where nails miss the rafters so that they can be seen protruding through the sheathing from below, and also overdriven nails that weaken the sheathing. The best way to ensure a strong roof is to fasten sheathing according to the current building code recommendations the next time you re-roof your home. But if you're not re-roofing, there's still other measures that can help strengthen the connections, and I'll talk about those. Gable end walls are common, and they can take a tremendous beating during a hurricane. If they are not properly braced and anchored, they can collapse and cause catastrophic damage to the rest of the house. Gable end wall strengthening is usually an easy fix because most of the connections tend to be accessible in the attic and can be reinforced without requiring major reconstruction. However, better connecting the roof to the walls is easier when re-roofing, if you're willing and able to remove the sheathing in the area of the gable. This gable end failed at the connection between the gable end triangle and the top of the wall. High wind negative pressures, in effect suction, caused the framing joint to bend like an elbow. This would have been an easy area to strengthen without doing any other repairs. In general, the taller the gable end triangle, the greater the risk of damage. Gable ends shorter than about 4 feet can handle most strong wind gusts, which is good because short gables are more difficult to retrofit. But every little bit helps. So even if you can't get to the ends of the gable triangle, strengthening the connections you can get to is better than doing nothing. Here we see both a gable end failure and a loss of the entire roof. In this case, the roof failure may have caused the gable failure. The roof can be entirely lifted off, even when there's no gable to fail. Here they lost shingles, underlayment sheathing, and the rafters. This kind of failure usually means wind got inside the building through a broken window or door. That's why wind codes require windborne debris protection on windows and doors in very high wind hazard zones and in coastal locations. The purpose is not to avoid having some broken glass. The real purpose is to avoid structural failure like this, from wind pressures inside amplifying the outside pressures. Wind blowing across a roof creates a suction force on the roof that is even greater on the downwind side. If a large window or a door is broken, creating a big hole in the wall facing into the wind, then the overall uplift forces that are trying to lift the roof off your house could be doubled. Protecting windows and doors can raise the hurricane intensity required to lift a roof off the house by 1 or 2 intensity categories. In other words, if the roof would lift off during a Category 2 hurricane if a large window broke, it might take a Category 3 or 4 storm to lift the roof off if all the windows and doors are protected. So find out the wind speed risk of your location from your local building permit office or search online for a wind design speed map. Then you can select your roof improvements to meet or exceed that number. The shaded roof areas shown in this illustration experience the most uplift in high winds. These are the areas where the attachment of shingles and sheathing must be strongest. You can get that extra strength by using a combination of more nails, a closer nailing pattern, nails that grip better, and/or suitable adhesive. You'll want the roof rafter to wall connection to be strong as well. It's best to refer to a wind code manual to select the most appropriate roof sheathing panel and fastener size and spacing. But still, in most wind zones, securing existing roof sheathing to rafters with ring shank nails spaced every 6 inches has been shown to be very effective. Ring shank nails, like those you see here, have ridges on them to make them grip and resist pullout. A strong, storm-ready roof needs wind-resistant roofing with high wind installation methods, wind and water-resistant underlayment, secure sheathing attachment, rafter to wall strapping, and gable-in wall bracing. So, when you are ready to re-roof your home, insist on a high-performance roofing system. Today, we are fortunate that much better roofing products and systems are available. You don't have to end up singing those blue tarp blues after the next storm. A high-performance roofing system needs to address all components: the roof deck and its attachment, edge protection, flashing, underlayment, and the roof covering or roofing material. Let's walk through the steps to a storm-resistant new roof and some additional opportunities to strengthen connections in the process. Step 1. Always remove the roofing and underlayment down to the roof sheathing. More is not better when it comes to layers of roofing. Layering actually makes it more vulnerable to wind damage. Step 2. Inspect and replace any damaged or decayed sheathing and framing with new material of the same thickness. In this photo, weak roof decking panels are marked for replacement. You can use either plywood or OSB sheathing, but plywood is best since it's more resilient to moisture. But be sure to leave a 1/8 inch gap between the panel edges to allow for expansion. This stage also offers an opportunity to strengthen the roof-to-wall connections by removing the sheathing on the outer edge of the roof to gain access and add hurricane straps. With roof sheathing removed to expose the roof rafters or trusses resting on the wall framing top plate, metal hurricane straps or clips can be installed to connect the rafters to the wall framing. Metal twist straps can connect a rafter directly to a stud if they are aligned, or rafter straps can be attached to both top plates. Connecting to only one top plate can fail in a storm, so be sure you're catching both of them. Now, top plates should also be strapped to the studs. The connectors can be all on either the exterior side of the wall or all on the interior side, but try to avoid having the roof rafter and the wall stud connectors on opposite sides of the same wall. Step 3. Re-nail the roof decking to the rafters or trusses for better holding power. Research has shown that the use of staples and the minimum size nails allowed by older building codes just don't cut it for keeping the roof from lifting off in very high winds. Ring shank nails have ridges that increase pull-out resistance and stronger heads to resist uplift. So specify 8D ring shank nails and 6-inch spacing into all rafters under the sheathing, not just along the sheathing edges. Step 4. Sealing the roof decking offers an added layer of protection from water leaks and damage to your home if roofing is damaged by a storm. There are 3 alternative methods for doing this. One method is taping the sheathing seams before installing 30-pound roofing felt. This tape is not duct tape nor window flashing tape. It's a 4-inch self-adhering modified bitumen or membrane tape that is approved for use on hot roofs. It can be used to tape all the deck seams and to seal roof penetration. If rain ever gets behind the roofing felt, it will not leak into the attic through the gaps between panels. Another method is to use a synthetic underlayment with very high tear resistance instead of conventional roofing felt, which tears easily in windy conditions. For best protection, secure it with roofing cap nails at 6-inch spacing along laps and tape all the seams with a compatible tape. This synthetic underlayment you see in the picture was fully exposed on a roof of La House Resource Center in Baton Rouge, Louisiana, yet survived both Hurricanes Katrina and Rita without one tear. It was incredible. The roofing felt on other unfinished roofs in town were all shredded by those storms. The third option is to apply a peel and stick membrane underlayment on the entire roof deck, which is essentially waterproofing the whole roof. This shows 2 types used on La House Resource Center roofs. If used on oriented strand board or OSB roof sheathing, a primer should be applied to the OSB before the membrane's installed because the waxes in the OSB can interfere with the adhesion of the membrane. Now, if you plan to have asphalt shingle roofing, some roofers recommend laying some basic 15-pound felt on top of the membrane as a bond break to keep the shingles from sticking or clinging to the membrane, which can make them hard to remove when it's time to re-roof in the future. It doesn't need to be heavily fastened, just held in place enough to install the shingles. Step 5. Proper flashing is crucial at all roof penetrations, where the roof intersects with vertical surfaces, in roof valleys, and at roof edges. Unless a peel and stick membrane covers the entire roof, it's a good idea to use the same product as a flashing system to protect vulnerable areas like roof valleys and where the roof meets walls. At intersections of the roof with vertical surfaces, such as walls and chimneys, the flashing should extend up the wall and be covered shingle fashion by the wall's house wrap and siding or other cladding. Durable drip edge should be installed under the underlayment on the eaves and over it on the rake, which is the edge of the roof gable ends. Step 6. Last but not least, for a strong storm-hardy roof, is the roofing material and ridge vent system that you select and how they are installed. When you're re-roofing, you may not have to meet the building code requirements that apply to new construction, but it's wise to get as close as you can to doing that. It might even qualify you for discounts on your homeowner's insurance. FEMA advises that roofing shingles be evaluated in accordance with the ASTM-D 7158 wind test. It classifies shingles with an easier-to-remember rating identification of Class D, meaning it passed a 90-mile-per-hour test, Class G, which passed a 120-mile-per-hour test, or Class H, meeting the 150-mile-per-hour test. The test that is used for Class F shingles is considered less reliable, so shop for Class G or H instead. Be sure to choose a class rating greater than the wind design speed for your location. Note that the mile-per-hour rating does not guarantee that the shingles will withstand an actual storm of that wind speed, but that it passed a standardized test of that wind speed. The manufacturer warranty will typically cover a lower actual wind speed. Also look for the UL 2218 hail damage test rating. They range from class 1 to 4, and 4 is the best. So the bottom line, if you want to be most storm hardy, buy shingles rated class H and class 4. That's what I did for my home's last re-roofing. For high wind rated shingles to perform as tested, they must be installed according to the manufacturer's high wind installation instructions, which are usually different from the norm. It's wise to look up those instructions yourself and discuss them with the roofing contractor before they begin, or better yet, before you sign the contract or the estimate. High wind installation usually requires a specialized starter strip along the roof edge instead of the traditional practice of just turning a shingle upside down as a starter. The dedicated starter strips have strong adhesive near the edge that bonds to the first course of shingles. If the manufacturer allows the use of shingles with the tabs trimmed off, it must be installed and fastened exactly as the manufacturer specifies, which may require adding 3 dabs of cement under every shingle tab of the first course as shown in this illustration. So it's best to just make sure the roofer buys and uses the starter that goes with the shingles. High wind installation of shingles also usually calls for 6 nails per shingle instead of the usual 4, although some products meet the rating with only 4 or 5 nails. Again, make sure the roofers follow manufacturer instructions for high wind installation. Use of roof cement is another recommended best practice on the gable edges and ridges, unless the high wind installation instructions don't advise it. Some important fastening guidelines. Use only roofing nails, never staples. If your home is within about 3,000 feet of salt water, use stainless steel nails that will resist corrosion from salt in the air. Use roofing nails that extend through the underside of the roof sheathing, and it's a good idea to check that the nails are not overdriven, crushing the shingles. Roofers should adjust their nail guns accordingly. Many roofing manufacturers now make roof vents, like ridge vent, that have passed high wind and wind-driven water tests. These vents are identified as having passed the Florida Building Code's Testing Application Standard, or TAS 100. All installed roof vents should meet the requirements of TAS 100 and be installed per manufacturer's installation instructions. As before, make sure the vents and openings for them are installed to manufacturer specs. There should be as much or more inlet ventilation area from the soffit vent than outlet area at the roof. But make sure any soffit vents are securely attached to framing, not just flimsy vinyl resting in a track. And for several reasons, power vents and turbines are not recommended. Today, there are TAS-rated hip ridge vents to get enough ventilation of hip roofs without the air quality and wind risks associated with power vents and turbines. When you are not ready to replace roofing, there are still ways to improve your roof's storm resistance. Let's start at the top. Aging shingles are not good at resisting hurricane force winds. The factory applied adhesive strips lose holding capacity over time, and sometimes the top shingle doesn't ever adhere properly to the shingle below it. So the first step is inspecting the shingles to see if the tabs are well anchored to the shingle below. To do that, use fingertips to gently lift up on the edge of the shingle tabs. Whomever does this, of course, should use a safety harness and other means to prevent falls, and personal protective clothing. As long as the shingles are still flexible enough to lift and to reset flat, they can be reset with dabs of asphalt roof adhesive using common tools. You can use a putty knife to separate and lift loose tabs so that you can apply the roofing cement. Be careful not to bend the tabs too far, since aged shingles often get brittle and may crack or break. To cement shingle tabs to the underlying shingles, use a caulking gun to place 3 dabs of asphalt cement about the size of a silver dollar under the tab. Press the tab firmly into the adhesive, making sure it lies flat, to reduce the chances that wind will pick up the edges. It's best to cement every loose shingle, but those at the edges and ridges are most important due to the higher wind forces at roof edges. A handy tip for do-it-yourselfers: asphalt cement will likely end up on your shoes and hands, so gloves and shoe covers are a great idea. When not re-roofing, there are also ways to strengthen the roof decking or sheathing's connection to the roof framing from inside the attic. One method is to apply a continuous bead of subfloor adhesive along both sides of rafters where they meet the roof sheathing. The adhesive should have an AFG 01 rating. Properly applied adhesive can increase the strength of the connection to resist as much as 250 pounds per square foot of air pressure. On gable ends where only one side of a rafter or truss is accessible, install the adhesive bead and embed quarter round strips of wood in the glue. Joints using quarter rounds with adhesive are about 50% stronger than those formed using only the bead of adhesive. An alternative method is to spread subfloor adhesive along two adjacent sides of 6-inch long wood blocks and attach them to both sides of rafters or trusses, spaced about 6 inches apart. Gable end walls can be reinforced to prevent gable wall failure and buckling of roof sheathing from high wind pressure. These improvements are usually not expensive and can be done by do-it-yourselfers in accessible attics. One method is to add blocking between the first 2 to 3 roof rafters or trusses and ceiling joists, and top them with a 2x4 brace at 4-foot intervals along the gable end wall. An alternative method is to use a cross-bracing system. Keeping soffit under your overhangs in place helps keep a lot of wind-driven water out of your attic and your home. In general, soffits made of plywood, fiber cement, or other solid panel material well fastened to structural framing can withstand most storms. However, lightweight vinyl or aluminum soffits and vents, especially those that just rest in J-channels and are not fastened to framing, are very risky. For secure soffits, note features on this illustration. A. Framing should be across the bottom of eaves or be added to provide structural support for the soffit. B. Nailing strips may be needed to provide attachment points every 12 inches for high wind zones. C. The manufacturer's receiver channel should cover the ends of the soffit panels if applicable. And D. The overall depth of the soffit should not exceed the soffit material manufacturer's limits. Although not as secure as solid soffits properly connected to framing, existing lightweight soffit material can be improved in place by applying a bead of sealant along the bottom edge of the wall channel to adhere it to the wall surface, followed by applying large dabs of sealant in the indentions. Surfaces receiving sealant should be cleaned first to facilitate bonding. Extra resistance can be gained by installing screws that tie the soffit panels to both fascia and the wall channel. Keep in mind that this method of using sealant is a temporary measure that is not a substitute for proper installation and fastening of soffits in a new installation. In summary, when you re-roof your home, replace damaged sheathing, add hurricane hardware, and re-nail with ring shank nails. Seal the roof, use a high-performance underlayment, and properly layered flashing. And select and properly install high-wind rated roofing and ridge vents. Things you can do when you're not ready to re-roof: secure loose shingles with roof cement, improve attachment of decking to rafters with adhesive or blocking, brace gable end walls, and strengthen soffits to stay in place. For more information, visit the FEMA.gov website and click on the Safer, Stronger, Protected Homes and Communities page for many free downloadable publications. The Extension Disaster Education Network, or EDEN website, is a repository of extension educational resources from all over the U.S. for every type of disaster. You can also see and learn a great deal about more ways to protect your home and family at disastersafety.org, the Institute of Business and Home Safety, and flash.org, the Federal Alliance for Safe Homes. And visit La House Resource Center's website and click the My House button to explore articles on best building and home improvement practices for high-performance housing in the southern region and the benefits such homes offer. If you're in the Baton Rouge, Louisiana area, be sure to tour La House Resource Center on the LSU campus. It's a permanent exhibit house and showcase of solutions for the southern climate and natural hazards, with cutaways, feature signage, and lots of displays and free publications to explore, learn, and benefit from. So, hope you never need to sing the blue tarp blues. Get a storm-ready roof. Step 5. Proper flashing is crucial at all roof penetrations, where the roof intersects with vertical surfaces, in roof valleys, and at roof edges. Unless a peel and stick membrane covers the entire roof, it's a good idea to use the same product as a flashing system to protect vulnerable areas like roof valleys and where the roof meets walls. At intersections of the roof with vertical surfaces such as walls and chimneys, the flashing should extend up the wall and start again. Let me pause.